So everybody, welcome to this first Foo Talk with Mattias from Lytics.
Thank you. Nice to be here.
Yeah, you're very, very welcome. This is so exciting. We're going to talk about artificial intuition. And I don't know if everyone knows what that is. So perhaps the first question would be to ask you to describe it, but I know that you're burning to tell us why we need it. So I will begin with asking you, why do we need artificial intuition?
Sure. So, in this discussion, I will be basing my point of view from the healthcare sector, which we're in. I'm sure there will be other applications for artificial intuition, but we'll talk about the healthcare setting here. And I think why we need it in the healthcare setting is because we no longer have an age pyramid, which means that there are few older people and a lot of young people. It's more like a age muffin, which means that there are quite few people that can provide healthcare for the older people. So just in Sweden, there are calculations done by the Swedish government that says that in 2025, we need 530,000 more healthcare professionals just in Sweden. And if you think of it, that's only like another 7.5 years, meaning that almost 7 out of 10 people need to go into healthcare for us to retain healthcare as it is. So this is a long answer to a short question. But anyway, which means that we have to do something differently in healthcare. And the way we do that is that we need to replace people, not replace people because we still need people, but we need to reinforce the workflows with artificial intuition. That's why we need it, because otherwise we won't be able to provide healthcare for all of us here in Sweden, and the issue is the same wherever you go in the world.
So,
But I'm not an expert on definitions what artificial intuition is, but it's when you use artificial intelligence to replace human intuition, which is mostly in healthcare.
yeah, and how do you use it in healthcare?
Well, we use it. Well, we build it, so we don't use it, but we're there when it's used, and we use it to reinforce the work situation for nurses and physicians, so they are able to look at more patients in less time with higher accuracy, or at least the same accuracy as they do when they look at a patient one by one. And it's very time consuming to look at a patient's charts because you need to go back and see what was the blood pressure 1 week ago, 2 weeks ago, 3 weeks ago, 4 weeks ago. And you do a lot of investigative work. And it sort of builds up a hunch. So when you talk to physicians and you say, oh, how come you reached that decision? And they say, well, I just looked at the chart. And yeah, but what did you look at? And then I just look at the chart because they have a hunch, an intuition. And it's the same when you talk to nurses that are watching sepsis patients. They can't really describe what it is that makes them make the decision. It's just something that it's not so tangible. So we try to replicate that by collecting a lot of data and analyzing the data, and we give suggestions. So we say we think this patient here is at risk. You should look more into this patient. You should prefer to look at this patient instead of that patient. And that's how we help the healthcare professionals sort amongst the patients and make it more efficient. So it's like an intuition built into a system.
So you say that we will be able to manage the coming workload by adding artificial intuition and assist healthcare in the healthcare professionals in
Yeah,
their
yeah, I think so.
decisions. Um, is there any other benefits from it? Is there some additional work that we accept from like handling more people?
Yeah, I think you can handle them more efficiently also. I mean, the first step is really to look at the patients and understand what is going on. The second step is to suggest what you're going to do with these patients. And I mean, IBM Watson is one of that kind where you can use it to identify and diagnose an issue. And that's sort of also a little bit of artificial intuition. So there are many applications. I mean, our sister company Expert Maker, they did this for Vodafone. So instead of looking at all the subscribers of phone subscriptions and you would figure out who are going to do a churn, that is, who are going to terminate their subscriptions, You can't reach out to all of your customers and offer them a replacement phone or something. It would be too expensive. So what you do is you do a churn prediction. You know, analyze all the data from these surprise subscribers, and then you reach a conclusion where you say, okay, let's look at 15% or 10% or 20%, as many percentages as you can tolerate with your operations. And then you focus your efforts on those groups. And we do the same in healthcare. So we work with physicians and nurses where they have 100 patients that they manage. And our goal is to reduce that workload to 20 patients and say, okay, if you focus on these 20 patients, then you will capture 75% of all the issues that you can overcome. And you can go deeper into the efforts of those 20 people. So, but there are many applications. I mean, artificial intuition is not an exact science. It's more suggestions. There are other uses of artificial intelligence where you can actually say yes or no, which is more of a binary thing. This patient has lung cancer, this patient hasn't, where you do image recognition and it's more a total knowledge. So there are various applications within healthcare and out of healthcare too.
What sort of data will be used for the applications that you have in mind?
We take everything that we can. We eat everything. Well, it's so let's say that you're a patient and you come to me and you ask me when am I going to get sick, then you better not bring your data from last year because I can't really tell anything. It's one thing if you come with your X-ray or your MRI image or anything else, I can say yes or no. That's what we can do. But it's much more difficult to say when something is going to happen. Then we need more high-dimensional data. So I think we are working prominently with chronic patients, so they tend to visit hospitals often. You get a lot of data. But for other, I think it comes down to wearables and other data that you can provide, heart rate variability and so forth. It really has to do with the outcome that you want to predict.
I know that you have some thoughts about patient integrity. Do you want to share them?
Yeah, patient integrity is like it's like pants. You know, it's weird if you can't protect the patient's integrity and their data, and I think that's a must-have, like a transparency. If you can't if you're not able to pull that off, you really have nothing to do in the business. So that's really really important for the patients to trust that if I leave my data to you, it's not gonna leak to an insurance company or someone else, and they can differ their premiums to me. They have to know that we take care of it. So we work very much with that. We use data offsets and all the HIPAA regulations to do that. I think it's just a basic necessity, really. And I don't see us as leaders in that field. We just follow the guidelines of the government. But I'm really thrilled about the harmonization of these rules, so they will be the same. So it's kind of awkward when you travel all over Europe and you have to use different currencies in every country, and it's the same with the integrity. So it's the same set of rules. So it's just a necessity to have.
How about ownership? Who should own my data?
I think the patients should own the data or yourself.
And what do you have to change to make that possible? Is it possible today that I could own my own data, or do you have a vision for the future?
Well, today you can, in many instances, you can get your own data, but how you're going to store the data, I think that could be problematic. I think the blockchain technology is promising with ledgers, and you can distribute data. I think that's probably going to happen in patient journals too. And then there will be like Microsoft Health Vault and other places where you can store it. And I think that's good. So I think the ideal position would be that you carry your data with you at all times, and you can choose whatever provider you want. That's the. I certainly don't want to have it locked into silos. That would be awful.
What would that look like? You say use it with whatever provider you want. What do you imagine?
Well, then we come down into interoperability again, which I think is going to happen down the stream. If you look at, for instance, accountancy, we just switch to another industry. They are using, even though you have different software like Visma, Fort Knox, wherever, you can use your accountancy in one system, and then you can pull out a SIA file, and then you can plug it into any other system, and you can just migrate your accountancy from one system to another. I think we're gonna arrive at the same situation here. We can take your data and just move it to another place.
So if someone watches this presentation in 30 years, what do you think that they will think is what will have changed?
I think everything that we talk about will
Hmm.
have changed, and I think in less than 30 years too.
Yeah. What time scale do you?
But I think less than 10 years. Not for all people, but in metropolis in Western countries for sure.
And what do you imagine? What do you think will happen
You mean with the integrity or overall?
overall with me carrying around my data and wanting to know when I will get ill from what?
I think that's feasible within 10 years, especially if you're a chronic patient, yes. If you're not a chronic patient, if you're more like a normal person with no risk, then potentially it will take a little bit longer time. So I think you probably an urgency to address the needs of the chronics first. But I think in the long run, I think that will happen, and I think there will be a lot of changes in the whole healthcare sector as well. I mean, today it's just a friend of mine. He's a doctor, and he was on a flight from South Africa to the United States, and there was one person who became very violent, and everybody was just in shock. What are we gonna do? And then my friend Dave, he just stood up and just hands out, "I'm a doctor," and everybody's, "Wow, what a guy!" He's like a semi-god. And then he sat down with this person and he calmed him down for the rest of the flight, and everybody cheered and everyone was happy. So I think in the old way, if you go back to the 50s, 60s, especially in Sweden, the physicians they had huge control. I mean, they could actually tend to a patient and say, okay, this patient has a psychiatric disorder, and then order that person to go into an asylum for the rest of their life. I've been working in that field myself. I worked with a patient that was 99 years old, and she was admitted to hospital when she was 19 years old. She'd been in an institution for 80 years, and it was just one doctor decided that. There's a huge amount of power in one person. I don't think anyone can fill that responsibility because if you think about it, doctors are really the sum of all of their experiences up to the day you meet them. So what you really want is someone with the experience. And the more experience they have with your cases, the more helpful they're going to be. But no one can have all the experience in the world. So I think there's probably a shelf life to the diagnostic ability of the physicians when it's going to be replaced by machines. That's what I think.
Mm, that's very interesting. Will it change science around healthcare as well? The
I,
research?
I think so. I think so. I mean, there's a lot of talk about evidence-based medicine and so forth. But when you think about it, and if you've been in the industry, you see these patterns happening where I guess you all know about the drug development and their phase one, phase two, phase three trial, phase four trial, and so forth. Maybe not. So you start developing a compound, you're doing feasibility studies, and then you have the phase three trial. Then you get it approved for mass market, and then they're often phase four trial. So Lytics, we also have electronic data capture systems, so we are part of some international trials. And some of them are phase four trials, where we actually reevaluate a drug or a therapy that's already on the market, which evidence-based clinical trials. And usually in a phase four, you do much more patients than you do in a phase three. And it's not irregular that, that the phase four trial is actually complete opposite to the phase three trial. So we've been part of two trials, one with sepsis medication and one with target temperature management, where the outcome was direct opposite of the phase three trial. I was working with heart valves, and we were competing with St. Jude Medical. And they had done an FDA trial where they had excellent results, and they were never able to reproduce those results. And then we just say, oh, well, how weird. What is the truth? Well, the truth is that we don't know what the truth is because as humans, we can't handle the complexity. So we reduce the complexity to like 4 or 5 factors, whatever we can keep in our head, and we try to just wishful wishful thinking to say, okay, this patient is a smoker, this patient uh, is violent, this patient travels to tropic places. We we want to disregard those facts about this patient. We just want to say that it's a man, about 60 to 70 years old, and a diabetic. That's all we care about. So we disregard everything else, and we just reduce the complexity to three different factors, and then we want to chase our p-values and see that we can sort of this hypothesis is true. And I think that's a little bit of a danger because then you make all your foundations on medicine on those things, and it turns to shift away. So, for instance, when I was born, my mother had one child in the 50s and one in the 60s and one in the 70s, and the procedure for having a child was completely different from the different times because they also varied with the clinical trials. So I think in the long run we're probably going to move away from the evidence-based because there's a limitation to the truth, and we're going to move into an individualized. We cannot treat people as cohorts. So just look at statins, for instance. I think you need to go up to 300 patients before you find one patient where it's actually doing any good. And it's just a way to market drugs. So I have a lot of thoughts about
Yeah.
that.
Do you think that there are any other ways that healthcare has to change to fully get the benefits from artificial intuition?
Yeah, I think so. And I think it is changing too. So a lot of things are changing. So for instance, here in Sweden, we have the fee-for-service program under the new public management. It was introduced in the 80s, which is sort of skewing the way we see healthcare. So if I'm a physician, I basically have a laundry list and I have different incentives. So if I can get you to stop smoking, then I get more money from my clinic. If I treat you the first time, I get more money than if I treat you for the 11th time. So those those payment system, they move in biases in how you build the healthcare. What's coming now is the outcome-based healthcare. I think that's a better move because then you're looking at, okay, how is the patient feeling? And you're actually paying the providers based on the patient's feeling, not necessarily if I try to sell you a stop smoking program or something else. I think that has a better benefit because if you want to use artificial intelligence, you want to use it on something that is true, so something that's not negotiable. Selling a anti-smoking program is negotiable. Dying is not negotiable. Either you are alive or you're dead. It's very easy. Either you end up in hospital or you don't end up in hospital. It's a good thing to predict. So I think the more we move to hard and good and solid targets, the easier it is for us as software companies and AI companies. So that's one thing I think that needs to change. And the other thing I think is the acceptance of the human limitations. We have to realize that even though you are very bright and I'm somewhat bright and all of you are probably much more bright than I am, we still can't look into all these factors and do it better than a machine can, I think. And if you move on to that, so you have the outcome-based healthcare, what comes next? The full capitation, where you will take responsibility for entire population and just manage them. Say, okay, I will keep these 400 million people as healthy as possible, and if I do it, I earn this much money. And then you have that responsibility, then you need resources like that. I think if you even want to look further into the future, I think if you have analytic programs, what would be the role of the doctor? Why would you need the doctor? Why would you even go there? Then you could go back to the medieval times where your barber was your surgeon because you already figured out with your data that I need a I need surgery. Maybe it's your what's it called? Bihole. I forgot the name. No, not bihole. No, the appendix. The appendix. I was saying, yeah, that's not bihole. Yeah, it is. Yeah, it started with that. So if you need to have your appendix removed, you probably arrived at that conclusion yourself or with your provider, your data analysis, and then you can just shop around and you can go to the provider which can provide you the best appendix removal. And there are already systems like that in place, not here in Sweden, but in other countries where you can actually go and see, okay, I need to have my appendix removed. Where's going to be the cheapest place with the highest? It's like Yelp or TripAdvisor for doctors, and then you can shop around. But then you reduce the responsibility of your doctor, and then the doctor will probably just say, hey, I just take responsibility for the appendix removal. I do nothing else. And I think it will be the same with drugs. You probably will have your own print your own drugs as well that are targeted for you on your data, and you will probably source the ingredients from different providers, and you print them in your own printer if you have one printer, or you go to a place where they have printers, and then you print your own drugs at a much lower rate, of course, but you can't sue the company if you end up. I think that's probably where we can head if we want to, but I think there will always be a differentiated healthcare because there are different needs. I mean, you may have a higher need for continuity, I may have a higher need for autonomy. So there will be more of a demand-driven market.
So there's a lot of opportunity, but I guess a lot of us work within software and like to do coding and bits and stuff.
Yep.
So what do you, Mattias, want from us? What should we develop for you? What algorithms do you want?
I want excellence. Excellence.
Excellence, it's everything. Is there anything you want us to research or develop, or or is it just the human engineering left before we can use artificial intuition to save healthcare?
I think it's a trial and error process. To be honest, where we need to be exposed to a lot of data and just be immersed into this process and get a lot of different problems to solve. And I think it will be possible because whatever problem there is, there will be solutions. For instance, autonomous driving, the software for that has improved because there's a need for it. Image recognition, that has improved because there's a need for it. uh, Speech to text also. So I think whenever we're faced with the problems, as long as there are people that are keen to spend a lot of time and energy, I think there will be solutions to it. Semantic analysis, I think, especially if we go back and we look into the journals, because so much information is actually written in. I think that's going to be helpful.
Since I've cheated and we've talked before, I also want to ask you about this with the limited amount of factors that we can take in as
Yeah.
humans, and how we can decide what we should look for. That it's this second that artificial intuitions that can learn themselves what kind of data they should look at. That is
I think they
also,
should look at all available data.
yeah. So we don't have to like tell them what they should look at.
Well, I think the rules of data science, they still apply. I mean, if we have several factors that are sort of look similar, then we do the pre-processing when we set up our algorithms and our workflow. I think that's still valid. But apart from that, I think we should have a very open mind. And we've been in projects where it hasn't been like that. You often have this evidence-based approach to say, well, we think this is a high chance of working, but sometimes you're surprised. I mean, we meet with physicians who've been in the field for 30, 40 years, and they have this wow moment when they realize that a factor that they didn't pay attention to turned out to be very predictive. So I think everyone will be surprised, and that's why we should really include everything from the beginning. We should be open-minded, and then we can reduce it after a while. Maybe we don't need to look at the shoe size for a while, but who knows? It's,
Shoe size can predict things like how big shoes you have.
yeah,
Yeah.
yeah. They say if you have big feet, then you have
Yeah.
big shoes. So.
So
No, but you never know because there are also properties in the data that we are a layman in medicine, we don't understand that much, and there are hidden properties in all the data that we don't necessarily understand. I mean, we work with dialysis. If you look at the time that a patient is hooked up to a dialysis machine, that sort of says you more than just how much time has elapsed. It also tells you the duration of the dialysis is sort of a secondary indicator of how much urea that has been processed. So I think you need a full understanding of what the variables are like before you exclude. So that's why I think as layman in the field, then it's good to digest everything and not have any preconceived ideas about it. What do you say, Matthias? Matthias is one of our data scientists, so
mm,
wrestling with this problem. we decided we should try to keep everybody in our company called Mattias. It's so much easier for us.
Yeah,
Reduce complexity, right?
yeah. Excellent. Questions before. Uh, uh, yeah. Do you want to talk more about data collection?
But it's not very fun.
It's not very fun. I thought it would could be something more tech
But
related.
but it's interesting. I mean, just look at the. We're sort of focused on the American market because that's half of the market in the industry we're in. But I think it's less than 7% that are considered healthy people in the US. So how do you build a healthcare system for a population that's predominantly sick? That's super interesting. You just think of the number of Fitbits that's necessary. And I don't think the solution is in Fitbits either, because people tend to wear them for a couple of weeks and then they sort of say, okay, I walk 10,000 steps a day, it doesn't change. Why do I need to wear this? Just tuck it into a drawer. So I think it's going to be some changes in how we operate to give our providers the information that they need to make decisions. Maybe implantable. There's some decent trials on that. So,
So how do you think that this will change future generations?
well, I'm hoping that we're sort of tackling the problem with chronics and how we can sort of reduce the hospitalization, make them more healthy and so forth. But ideally, you would start in the beginning, early life. I mean, if you're a teacher, then you probably want to start in kindergarten because you can really change something. When they're 16, 17, then you can motivate them, but you can't sort of recap the lost time. So I think that would be the idea, but then you would need to capture the data. The genomics would be interesting because you can sort of see into the future, do some editing maybe. That's interesting too. But I think we need to move from being more reactive in the healthcare to being more proactive in the healthcare. That's probably going to change too. If we can solve the other issues with integrity and accountability.
The other issues.
Because it's so much more powerful if you know that you're going to have a heart attack in 394 days, then you're probably more likely to do something about it and change your habits. And the patients we are working with, the reason that they have the diseases that they have is usually, well, it usually comes down to how they live. They tend not to be the most compliant people that we're working with, and there's a reason for that. But if you know and you can see into your future and you can visualize your heart attack or whatever it is, then I think maybe that resonates with us all.
So you would say that sometimes it's easier to trust a machine than a person?
I think maybe you're more honest with the machine than you think.
Yeah.
But yeah, sure.
Yeah. Great. Hi. Yeah, no, I think also like one of the main advantages with artificial intelligence and algorithms is that you can weigh in many factors. Like because the human can't grasp more than 5 to 10 factors at the same time. It's very hard to deal with that kind of complex information. Whereas like I think when we do the dialysis, I think we use 64 different factors.
Yeah,
Yeah, and we're aiming to get even more, which we can weigh together. And this is like the main benefit, like where with using an algorithm, AI algorithm instead of a human.
yeah, and the computer is more accessible too than the doctor for many reasons.
And you can't really be offended by it.
No, it's really hard to be offended. It's sort of the cold hard truth that you need to.
Yeah. It's not you only say this because I look fat. It won't do that.
No, no, and
We
I think we're also another thing that's sort of important is we're working in cardiology. We've been looking at the entire Swedish population of cardiology, and it's interesting because when we talk to these physicians and these professors, they say that most of the solutions they are done in clinical trials for men, so they tend to be more the interventions tend to be more adapted towards men. So if you're a woman, then you have a less likelihood of being successful with the intervention because the clinical trials are made on men. And I think that's something that we move away from also with artificial intelligence. So that's one of the key reasons that we're interested in pursuing this in cardiology, because it will be more efficient for women. So it will be a greater equality of care.
So not only things tested on 20-year-old male in the military.
No.
Yeah. We have like 10 more minutes before the pizza's here. We've been efficient.
Yes.
I think. Do you want this time to think of your own questions and submit them? Is that a good use of time? It's Yeah. If you have Twitter, you can tweet on Foo Café. It's underscore before and after Foo Café. Or you can. There are notes over there and pens. You can send them around if you want to. And
You're
then
working on your data capture here.
Yeah. Yeah, it's a hard thing.
It is a hard thing.
Yeah, we can't assume that everyone follows the foormat Twitter. So um, we're thinking about the format, and I thought that it would be easier to have it like moderated and gathering questions. But if you feel comfortable,
Yeah, I'm comfortable. Yeah.
Okay, then we like raise your hand, get my. No, it's okay. We're agile in this company. We're very agile sometimes. So I think we just iterated on this format. And do you have a question? Okay,
Oh,
then I'll
wow.
hand you. Then I'll hand
Shoot.
you the mic.
I guess, I mean, I'm a layman, so bear with me.
Sure.
I guess then my first question, I mean, you give us so much information that it's, I've been having questions since the beginning, I can't remember. But I want to, you talked about fee for service approach, which is
Yep.
something that we're trying to stray away from
Yep.
in the future, for something that's a bit more like pay for outcome.
Yep.
But then you kind of went back to sort of a format in which patients they know already what they need and they just go and like buy a surgery from somewhere.
I think that would be one of the opportunities.
Isn't that a bit backwards when it comes to isn't it pay for service?
It would be. I foresee that we'll be moving to full capitation, but I think when we have the power of artificial intelligence, I think we can break free from that, because I think that some individuals, and I see this as a general trend, that we're moving towards individuality. We want more control of our lives, and I think that some people will opt out if they can, which means that you will take full responsibility of your healthcare yourself.
Right.
You only pinpoint whatever you need from certain individuals. But
Right.
that is on the basis that we have the data flows where we can actually empower you as a patient, as a human being, to be as effective as the whole healthcare system from your living room.
Right. Because I am picturing the scenario that happens now where doctors that are paid for service are doing or unnecessary surgery, for example.
Yeah.
I know the scenario in Brazil, for example, is terrible. It's outrageous how many of those happen.
Yeah.
And I'm picturing in the future where patients have full autonomy, but still there will be space for that.
Yeah.
Or a picture, but yeah.
I think I talked to physicians and they see a trend already from the rural areas and the metropolis areas. So at the rural area, they're more old-fashioned. They don't know so much about their disease. They come to the doctor from beneath. The doctor is like a god, and they trust everything the doctor says. Where in more metropolis, they bring 54 pages and then they want to educate the physician on their disease and tell them how much they know, because they don't want to be screwed around by the physician. So I think that's sort of moving in that trend where you don't want to be left out and you don't want to be a subject. Yeah, I think so.
Yeah. It's very interesting talk. I have a question concerning a bit of knowledge and philosophy here, because as I see it, is that you build a statistical model of the categories. Is that correct?
Well, I would make a distinction between statistics and AI, mostly based on culture and the use of software.
Yeah.
So where statistic tools tend to be more that you study something and you learn something. Where yeah
Yeah, it's
yeah
just that it's different. Yeah. So this is very different from, for example, if we take a model of some statistical techniques looks.
yeah.
So, um, how is this really a good model of the world?
I think so. Yeah. But I'm happy to hear what you seem to think differently, so I'm happy to hear that.
Okay. No, I can agree with you in many cases, because I think the knowledge about the world is more and more complex, and you have more and more variables that you have to handle. And as you said, normally you can handle 5 to 8 variables in that, so you can see a model, and it's very difficult for us to imagine more than 3 dimensions.
Yeah.
It is very natural. But the machines can imagine how many dimensions. There's no limit to it. So we have a lot of mathematics that can solve these problems, and there are also new types of mathematics that make it so topology. And with topology, we can solve problems that invariance to, for example, sensory data.
Yeah.
It's very difficult to handle.
Yeah.
So that's something that you also are looking for, or using different types of methods. To,
Yeah, we're using many different kind of methods, so I think you will be more apt to answer that question.
Methods very specifically. I mean, and
Yeah, sure, sure. Go ahead.
yeah. So we use random forest typically. Yeah, and also we use ensemble models with this mix of different models. And so I mean, sorry. No, no, not mixed models, even ensemble models. So that's saying we could use both random forest and then add another logistic regression. Well, random forest is actually like it's actually an ensemble as you calculate multiple trees. So then what we're saying by the tree, using a tree model, decision tree is more or less saying that like, yeah, hey, if this patient has a value on this side and then goes on this side on a certain criteria, then it should end up being this probable of being hospitalized within 30 days. And that would be saying, well, I think it's also interesting what you're asking for us is how much do we learn from reality? from this. It's the seriality saying, yeah, it's a hospitalization built as if a bunch of random trees where you get a score for each side. Yeah, well, I mean, what we're actually working on now is doing more intrinsic analysis of what's actually going on and what are like the key elements. Because this is pretty crucial for all machine learning. This goes on in deep learning, the deep learning community too. That people are saying, yeah, we produce the what do you say, state of the art results within the field for some problems, such as computer vision. We don't know why. Why does it work that bad if it's kind of like yeah, yeah. Yeah, but that's been the main issue, and I guess you have been acquainted with the Chomsky and Norway debate. Yeah, which is about this. Um, but so that's more saying, well, hey, we just know we push the button for the mathematical algorithm. It explained why the moon, the sun goes up every morning and goes down during the night because we could calculate this exactly with our supercomputer, but we don't know why because we cannot see, you know, the the Earth rotating around the sun. But what I think is more like in this case, I think my argument for our model is also that we actually learn something from doing this back and forth within AI, that we also can more of a like get like insight from actually getting complex data in. And I think that goes for other fields, even such as like computer vision, where I would argue that we have found a lot of interesting things. Yeah. Mm. Mm. Yeah.
Do you see a risk in this, that during the analysis you are doing it, the analysis, and maybe some other companies are doing some more accurate analysis and they are selling their service cheaper and then get
Yeah,
segregated in the
that's the way the market works.
uh,
So I think there will be. I don't think one company can solve everything. That's probably going to be impossible. So I think there's going to be just like plugins into this whole system, and I think we probably have a good position where we're at right now. We're leaders in the world. What we do, that's a good position to have. But there are other areas where we wouldn't know anything about it. So I think it's just like that. It's computer science is very binary. Either you're the best or you're not. It's the way it is.
I feel it's more critical if I think about like having a service for my health than having a service for my
Yeah, I agree. I agree. But I think that comes in with you have to be the best at what you do. So we're working with it. So we're doing a clinical trial with our software. So we're comparing it with the golden standard, and we're looking at real art outcomes. So we of course uh, wary of this problem with overfitting because that is a typical problem within data science. But we're working measuring in real life patients. So we're doing live predictions. That is, we're saying to the clinicians, these patients are going to be hospitalized within a month, and then we can see after 30 days how many rights we have. We can't really overfit in a live setting. So and since we're working in that setting, we're getting better and better. And I think that would be the way to go if you would do this in dialysis. Dialysis work in dialysis, but diabetes or cancer or whatever setting you're working in healthcare, would recommend that.
So, just to understand the relationship or like how this for the patient
Yeah.
works. So you have an intuition that this patient is going to be hospitalized or this patient will have these kind of problems.
Yep.
I'm trying to understand the relationship because then after that, then there needs to be some sort of treatment
Yeah.
for that condition.
True.
And that treatment is still, I mean, isn't still our best shot, clinical based, clinical evidence based
I think
treatment.
I
Because
think
we're talking about
yeah,
how
I think it is, but I think it's changing. So we're working on that. For instance, we're working on prescriptive care.
and how's that?
Well, it's also based on machine learning. So if you look at a patient like yourself and your age and your composition of all your variables, and then there's been thousands like you before, then we can look at the history of those interventions for those patients, and then we can match it with you, which might be a better idea than comparing you with guys in their 20s in the military in the US.
Right.
So it just might be there, but
It's just a better way of doing everything.
it's a hypothesis that it is. I mean, no one is really doing it yet, so
Right.
so we don't know.
Right. No, I just wanted to understand because
I'm a proponent of what we do, of course, but
okay.
it's just it would be it would not be scientific of me to say that it's proven, but it's I think it's certainly feasible.
So, I've got a question, kind of in relation to the earlier question about risk and challenge, and kind of around the same area as, how the data is interpreted. Like for me, for example, if I were to feed the machine my history, my
Yep.
data, my statistics, how do we delineate, or at least kind of specify an accurate limit that this provider will interpret my data the same way? For example, so I feed my data, let's say it's an app on my phone, and it recommends that I go for an appendectomy based on my symptoms, and then I feed it to another provider, and it tells me I have a 75% probability of a heart attack. How do we, come up with an accurate model of inference for the machine that based on all these factors? Because I'm sorry, I think it's quite a mess, but
Yeah.
it's also related to this question I have in my head of the ownership of the data, right? Because once I give you my data,
Yeah.
then you have to aggregate that with everyone else's data in the room. And so the ownership or integrity of my information is kind of blurred now, and everything's blended in, it's fed into this machine.
I'm not sure I agree with you because we can build our algorithms for patients like you based on other patients. So it's freestanding from your data. We can apply our algorithm on your data based on who you are. We don't need to mess your data with the data that we already
Yeah,
have.
it's not
So
going to
so
mess
that's
with
sort of
anything.
separate. And I
Okay.
think it also comes down to the question that you ask us. So if you would go to us and we see what we could do for you, we could probably just provide you a risk score within the context that we are operational in. But if you're concerned about hypoglycemia or something, then you would go to another provider. And in the end, I'm not an oracle, but potentially it could all be linked to one great service where you have different providers providing their own niche. So you could get if you would send your data into such a service, an umbrella organization with, I don't know, 200 providers maybe, then you would probably get a risk profile. And from us, it would be that your risk of being hospitalized for dialysis would be 0.2%. And we're sort of kind of confident that we're in that range. Then you can say, okay, maybe that wasn't so helpful because you don't have end stage renal disease, so you don't really need to go to us. But when you go to another provider and you jump into their algorithm, then you get an answer from them. But I think the challenge is to cover everything, right?
Yeah, I was just mostly concerned, like, if I would come to you and you would recommend this intervention, another would recommend separate things. Just a bit concerned about the margin of error and accuracy, and who will I trust out of these providers?
Yeah, and you have that exact dilemma today too, right? So, but it probably be at this. I foresee that it's going to be the same dilemma, but at a higher precision. So it would be wise to take second opinion even in the future. That's likely. Yeah, yeah. Yeah, if you die from our services, I hope you report it.
I have a follow-up question on that one. Do you think that we will donate data the way we donate blood in the future?
Yeah, I think so. Yeah.
That would be a difference from everyone just taking our data without asking us first.
Yeah.
Um,
These systems, I mean, if we now give contradictory advice, shouldn't you have to have these trials on them?
Yeah, we do try.
Approved?
We do try it, and we do have
Yeah,
proof.
but then they shouldn't give contradictory advice.
I'm not sure that they will.
No. but maybe you have some incentive to. You might develop something that is more likely to advise you to buy control of the drug you sell.
Well, if we had that inclination, yes, I think we could, but I will
You
see.
might not, but someone else might.
Yeah, I mean that's everything comes down to trust. I think that's the way. But if you look at it traditionally, I mean, I've been in the medtech industry. I've been working close to the drug industry as well, and I can tell you numerous stories about physicians calling medical companies and asking for tickets to Hawaii for their family. So I mean, that's nothing that is new. And I think with the trust and especially with the culture on the internet today, you will get reviews how helpful it was. And today you can't survive as a company if you're that crooked. I don't think that would be possible.
Another question as well about the sort of knowledge here that humans do in computers.
Sure.
So how will that evolve? If we have systems giving advice, we don't need human doctors to do that.
No, I don't. I don't think we do. I don't think we need.
And then you sort of lose people that have knowledge. But what you move it into computers, but where's the role of the humans?
Well, yeah, I think so.
Scientific.
I think time will tell. I think it's hard to say, but I think the diagnostics. I think we will empower the physicians and the nurses with tools, so they will be helped by them. But then will be probably more on the treatment side, making sure that the treatments actually work. You know, the behavioral side and telling and pedagogics of the treatment for those that require those services.
How do you judge how a person feels? The outcome to be.
That's true. That's true. We well, you can, but you're not sure that you can trust it. That's a tricky question. I don't think I can answer that right now. We're looking into that area too, but we're in the beginning of it. It's difficult, but you're onto something there because psychosocial factors are very important in predicting how we feel. So that's a key element.
You asked before here about the people are donating their data. I would say that today it's probably like gold for you to get information from everyone. How do you see that in the future? Will people share it freely? I mean, you get the data from hospitals.
Yep. for this.
So I know if in the future, will people share data with you? So people will run around
Yeah.
somewhere, and will people share freely? How do you foresee that? Because if the development that you're looking for in the future is to collect lots and lots of information people are holding on to, it's difficult to do.
I agree. I agree. It will be. I think most people will share.
Yeah, I know. 50 pages. Yeah, I do. I mean, Google is a good example because they are seeking marketing information, but they
Yeah.
don't.
Yes.
They hold on to it. So you're kind of the data that you're looking for
Yeah.
is similar. It's a golden nugget.
Yeah. Right now, it's kind of a data war. I mean, there are big companies, so name names, but there are big companies sending lawyers to the Swedish healthcare system and saying, well, your data is public. You have to provide it to us so we can crunch it. And I think that's the wrong way to do it. But I think in the end, if we all want a better healthcare and we believe that this is the way, then we are probably going to donate our data so everyone can benefit. And I'm not just talking about Lytics. I'm talking about everybody.
In Sweden, you can't get if you're not connected to a hospital, you can't go in there and say, hey, I would like to get all the data for all the cancer patients, for example. You
Well,
have to have an agreement with that hospital.
I'm
With
I'm
the
I'm not a
government.
lawyer, but when I talk to the clinics and they say that these big companies are pursuing their data, they can't really do anything about it. I think. And they say, wouldn't you rather work with us on solutions? But these companies, they don't have the infrastructure to do that. So they just want their data.